Hello student, I welcome you all for our next lecture. Today we are going to discuss our next important topic, that is GSM radio subsystem. In the last lecture we have discussed your GSM architecture. In your GSM architecture we have four different categories like mobile station, base station subsystem, network switching subsystem and operating system subsystem. Okay. Today we are going to discuss our next topic, that is GSM radio subsystem. It is basically the next topic in your third unit. Basically your GSM radio subsystem uses 225 megahertz cellular band. And what is this 25 megahertz cellular band? We will discuss in this lecture. Okay. Basically in your GSM you need to transfer the signal from mobile station to base station. Again you have to receive the signal from base station to mobile. For that purpose you need an cellular band. Then for this your GSM uses 225 megahertz cellular band. And how it will use? The first nothing but that is your 890 to 915 megahertz band, means your 890 to 915 megahertz band is used for the subscriber to base station transmission. Means this band, means 890 to 915 megahertz band, basically used for transmitting the signal from subscriber to the base station. Means when we are calling any subscriber, first your frequency band is being transmitted from subscriber to the base station, called as the reverse link or uplink. It is called as the reverse link or uplink. Means when you are transmitting the signal from subscriber, means from yourself to the base station, then that is called as a uplink. Means when you are transmitting signal to the base station, that is called as a uplink or reverse link. You can consider uplink. Okay, we have to consider one, that is nothing but uplink. Okay, means for that purpose, for which purpose? Subscriber to base station you need 125 megahertz band, that is nothing but 890 to 915 megahertz. Okay. Now second, that is from 935 to 960 megahertz, means in between these two frequency band, that is 890 to 915. After 915 it is from 935. Okay, means there is a gap. How much gap? That is nothing but your basically 20, 30, 35, means near about 20 megahertz band gap in between your uplink frequency and downlink frequency. The downlink frequency is from 935 to 960 megahertz, that for base station to subscriber transmission, which is called as a forward link or downlink. Means for your GSM system to transmit the signal from subscriber to base station or base station to subscriber, there are two frequencies, that is uplink frequency and downlink. Uplink means from subscriber to the base station and downlink means from base station to the subscriber. Uplink frequency is from 890 to 915 megahertz and downlink frequency is from 935 to 960 megahertz. Basically your GSM has maximum 200 full duplex channel per cell. In each cell you have maximum 200 full duplex channels. 200 full duplex channel means your one base station can carry up to 200 user or 200 channel at a per cell. Means it can give the 200 channel to different cells. Okay, each frequency band is 200 kilohertz, that is 0.2 megahertz wide. Both uplink and downlink frequency band consist of 124 channel. Means your uplink and downlink frequency band consist of basically 124 different channels. Each frequency channel supports 8 separate connection using TDMA. Means each frequency channel supports 8 separate connection using TDMA. Means you are using in your GSM, you are using which technique? Time division multiple access. You are not using frequency division multiple access. Means each user is given a particular frequency for a limited time period. Okay. Each TDM slot consists of 148-bit data frame, and each data frame starts and ends with 30 bits for frame D-line purpose. Okay. For each TDM slots, it contains a 148-bit data frame. If you see this data frame, this is nothing but your data frame. Okay. This data frame consists of 148 data frame. Okay. That means sent by up to, it requires time to send this data frame. The time required is 544.7 millisecond. That means it is very small. This 148 data frame consists of in starting bits and ending bit with 000. That means 3 bits are reserved for 000, means there is no information. After that, 57 bit contains information, then sync contains 26 bit, and your information contains again 57 bits. Okay. So your each 148 bit data frame starts with 3 zeros. For frame delineation purpose, it also contains, means these 3 zeros basically will protect your data. Okay. It also contains two 57-bit information field. It contains two 57 bits information field. Okay. Each having a control bit that indicate whether the information field is for voice or data. Okay. There is an this is nothing but your information. Okay. Then this information contains for voice and data. Between the information field, there is a 26-bit sync field. Between this information field, that is this 57-bit, there is a sync field that contains 26-bit. Okay. This 26-bit sync field, which is used by the receiver, it is basically used by the receiver to synchronize to the sender frame boundaries. Means there must be a synchronization between transmitter and receiver. For that, we need 26-bit sync field. Each data frame make up a TDM frame, and 26 TDM frame makes up to 120 millisecond multi-frame. Okay. Of the 26 TDM frame in a multi-frame, slot 12 is used for the control, and slot 25 is reserved for the future use. Okay. If you see this slot 12 in your TDM structure, this is nothing but your frame structure. Total frame structure means you have 32,500 bit multi-frame which can be sent up to 120 millisecond. We are considering one frame. Okay. We are considering one frame. There are total 32,500 bit multi-frame. In that, 12th number is control, and then 25th is reserved for future use. Okay. We have already seen here. Here you can see the TDM frame. Okay. 8 data frame make up to a TDM frame, and 26-bit frame makes up to 120 millisecond multi-frame. 26 TDM frame is multi-frame. Okay. 26 is nothing but your multi-frame. Slot 12 is used for control, and slot 25 is reserved for future use. Means slot 12 is used for control. This is nothing but control slot. Okay. All mobile station monitor their signal strength to see when they have moved into a new SIM. The dedicated control channel is used for locating, uploading registration and call setup. Each base station maintains a database of mobile station. Okay. The GSM has a common control channel which is split up into 3 logical substations, that is paging channel, random access channel and access grant channel. Okay. You are basically, this is nothing but your GSM TDM structure. Means whenever you are transmitting the information, you have to transmit in a time domain. Okay. Means you are not transmitting in a frequency domain. Whatever be the information you are sending, that will be frame in a particular structure. If you see this frame structure, okay, we are seeing the frame structure, that is this frame structure. In this frame structure, you are having 8 different bits, means 8.25 bits, which and there is a gap between each bit, that is 30 microsecond guard time. Okay, this guard time basically used to separate your data, or voice data or information. Okay, for 1250 bits TDM frame, this TDM frame will require 4.615 millisecond. Okay, if you consider one frame, it contains 148 bit data frame which can be sent in a 547 millisecond. In one bit you are having, in one frame you are having starting bit 3 zeros and ending bit 3 zero for the protection of your data and information. In between the two information field there is a sync field to synchronize your data when the receiver will receive that particular data. Okay, that is nothing but the GSM TDM structure. That is nothing but your GSM TDM structure. Here you can see that reverse channel frequency, forward channel frequency, absolute radio frequency channel numbers, frequency spacing, frame period means when you are transmitting your one frame, you require 4.615 millisecond. User per frame, you means each user can use 8 different frame. Modulation data rate 270.83 kbps means when the data or voice data is transmitted, the data transmission rate is 270.83 kbps. Time slot period 576.9 microsecond means when you are talking to any user, you cannot notice there is some delay or there is some time required to transmit your data. Means your data encryption, decryption requires some time. That time is in microsecond, and your modulation is GMSK, and interleaving is 40 millisecond means there is delay up to maximum 40 millisecond, and the frequency spacing in your bit is in your frame structure is 45 megahertz. That is nothing but your GSM radio subsystem. Okay, thank you. Here we have completed our GSM radio subsystem. That's all for today's lecture. Thank you very much.